So here we are back on the Calliope project after a delay of 8 or 9 weeks. And I'll get into that and why that happened in a minute. But what we're going to try to do here next is drill the throttle shaft bores. So the throttle shaft bores on this thing, they go right down through the middle of the bores here, and you can see from these kinds of bulges in here that they were designed, or at least the casting was designed, to have the throttle shaft go all the way through there. So that's a distance of almost 20 inches, and this is a pretty big machine. This machine has a 35-inch spindle nose to table dimension, but that's still not enough. You would need to have 40 inches minimum, probably more than that actually, in order to get through there, because you need a long tool. So the approach we're going to take on this, instead of trying to do it in one piece, is to cut this area here out of the casting and just go through 2 of them, and that way we'll have 2 separate throttle shafts. It's still a pretty long reach. It looks like you need about 9 inches from the top of this, where the drill and the reamer and so forth start, to get down into this area here. And so there's barely enough room for that, even on this machine. But that's how we're going to do it. Now, of course, to do one side, we can do that. We have to rotate it 180 degrees to do the other side. And the problem with that, of course, is that if there's any setup errors or any issues with getting the casting perfectly lined up, you may have these 2 throttle shafts, these 2 half throttle shafts, not lining up perfectly. But we have a solution for that. Came from my friend Kelly Caulfield. Kelly and I worked a little bit on getting my Autolite inline 4-barrel carburetors taken care of, and Kelly suggested this little unit right here. So this is from Kinsler, and it's nice because it's got a throttle arm on it right there to make the linkage easy. But not only that, it will actually compensate for some misalignments between the two throttle shafts on either side. So this works out pretty well. So then, after deciding to do it that way, the only thing we really had to do was come up with the tooling for it. And here's some of the tooling. Now, the 12-inch drill is pretty easy to find. You can get those off the shelf. But this spotting drill here and this reamer are not easy to find. And so I had to have custom tools made up for those, and that's what took all the time. The other thing about this is that, even with a standard ER16 tool holder like this, you're giving away 2 inches right off the bat, which is too much. So I ended up acquiring some of these guys here. These are ER16 tool holders that are special. They use that spanner wrench there to close up that nut to lock the collet into place, and that buys you 2 inches. And between these long tools and this guy right here, we're going to be able to do this. We'll come back a little bit when we get into some machining operations. There's things we got to worry about with this. For example, there is no way you can change tools with the part sitting right there. It's got to move all the way over to the right, and then you can change tools. Because you get a long tool coming out of that spindle. If this thing's in the way, it'll just snap it right off. So you have to be careful about that. Once you get the tool in the spindle, you can't just move directly over there, because it'll hit the fixture, or it'll hit the part of the head and it'll snap right off again. So you've got to kind of jog around the thing to get the tool lined up properly. But once we do that, we should be able to spot the top, drill down through the first hole opening, then change to the spotting drill, spot at the bottom of the first throttle bore there, and then go back to the drill, and then go back to the spotting tool and spot to the bottom of the second bore and go back to the drill, and then finally put the reamer in and go through both of them at once. Of course, first, this has to be cut away in here. So we're going to do that first, and then I'll try to get some videos of the machine running doing the longer tools. Okay, so here we are getting ready to drill and ream the throttle bores on the first half of this Calliope head. You notice how long that tool is. We need to get that drill all the way down halfway through the head. And so with the spindle, even up at the max travel there, you still have to be awfully carefully make sure you don't run it into the casting or into the fixture, because you just break it right off. So that takes a little bit of special moves on the CNC machine to get there. Now we've already drilled through the first section here and down into this section here, and we've cut out this center here so that we'll have some place for the drill to pop out on the bottom. And what I'm going to show you is just the last spotting operation. Every one of these bores, since they're circular in the bottom, they've got to be spot drilled before you can try to drill them with a regular drill, because there's no way this 12-inch long drill is going to stay straight if it hasn't got some starting point there. So that's what the spot drill is for. So we're going to see if we can get that started up here, and we'll show you the last spot, the last drill, and then the ream of the reamer going through the bores. So let's see if we can get that done right now. So first we're going to change to the spotting drill, which is also a very long drill. A little scary to see how that's close enough to this thing, but as long as we maneuver the machine correctly, we can do that. So, and this is going to come almost all the way down to that grill. Just spot it right there like that. And come back out. Then we're going to change the drill and drill that last little bit. Drill it down from there. We'll do that through all the coolant, but what's going on? Short tool holders, we're able to get that done. Move this guy out of the way again, and then we're going to go to the reamer. And now we'll get the reamer going through there. This is a boring cycle. Okay, we're back here with the Calliope Machining again. The last video got interrupted before the end because the battery on the camera died, so sorry about that. But in any case, we did finish that one side and have now finished the other side of the throttle bores, and everything's come out pretty well. I've got a test one here, or a test shaft here. I'm going to put that in there like so, and it slides in there nice and spins pretty nice. It'll be a good throttle shaft for that. This is just the kind of thing we're going to use to make the actual throttle shafts with. So now the last thing we have to do on this particular setup is to do an angled boss for an angled oil hole. Goes into a boss. I'm going to see if I can show you that here. See if we can twist this thing around without hitting anything. So this boss right here gets an oil hole that goes in at a 6-degree angle. Now if I had a 5-axis CNC machine, I could just drill that, but I don't, so I had to build that into the fixture. And so the way that's going to work is there's some pins in the fixture. There's one right here, and then some bolts. There's 4 bolts like this, and there's also a second pin up on the other end. Over here, right there. So when we loosen these 4 bolts, we can pull this pin out and the whole fixture will rotate on the bottom pin that I just pointed out. And this one goes into a new hole, the bolts go into new holes, everything gets clamped down, and suddenly we've got this whole thing at a 6-degree angle, and then we can drill that hole. So we're going to do that now, and show you what it looks like when we get it fixed. Okay, so now you can see I have moved that fixture plate. It's at a 6-degree angle, and the boss that we have to put that oil hole in, which is right here, is now vertical, so we can drill straight down into that to get an oil hole into the cylinder head. So now that we're done with that flat fixture plate that it's mounted to now is pretty much done with. We're going to be taking that off. We have to put in the end pieces that bolt onto either end of the casting. And I haven't machined those yet, so it'll be a few weeks before I get that done. But once I get that done, then we can put the casting axially on the fixture and start machining the valve pockets and the valve spring pockets and the injector runners and all of that stuff in earnest. So I'll get another video up when we get to that point.